This video covers topic 15.3, which looks like this page, Transformations of Quadratic Functions, day 3. So at the top, we are asked, we are given the transformation form of a quadratic function, and we're told that it is expressed like this. And we are restating what all of these things do. So the vertical translations deals with k. K is at the very back of our function, so that's where we decide if we're going to kick it up or kick it down. So if k is greater than 0, so if k is positive, then the graph will shift up. And if k is negative, the graph will shift down. So you might want to put plus k and minus k, just to remind yourself. This is also listed on this paper that we did yesterday, so this is just us kind of reviewing it. H on the inside with x tells us how we're going to move, how we're going to translate horizontally, so H for horizontal. Remember, what is inside with x is always the opposite. So if H is negative, if it looks like this, we really go to the right, because in our formula, the negative sign tells us it's always the opposite of what we think. If H is positive, so we have x plus H, we go to the left. So inside the parentheses is the only thing that is the opposite of what we normally see. A and K, whatever it says, is what it does. So if A is greater than 1, so something like a 2, the graph will stretch vertically. So remember, that means it's going to be skinny. If A is between 0 and 1, something like 1/2, it will compress. So that means it's going to be wider. And when A is less than 0, such as a negative number, the graph reflects across the x-axis. Keep in mind that only one of these things can happen. You can't stretch and compress. And this one is separate from the other two. So you can reflect without stretching or compressing. You can compress or stretch without reflecting, or you can do both things. So if there is a negative in front, you reflect. If there is a number in front, it's stretch or compress. And if you have both, you do both. Now I believe this part is already listed for you. If given this form, the vertex can be found at whatever the opposite of H is and K. So H is always the opposite sign of what we see, and K is the same as what we see. So we've kind of started this for you because some of these are really weird. What they're asking you to do is write an equation and describe the effects. So we're going to describe the effects, but make sure you're listening on how I wrote these. So they tell us f of x equals x squared. So anywhere we see an f of x, we replace it with x squared. And then they have given us k, h, or a values in which we are replacing the numbers wherever they are. So here they tell us k is -1, so instead of putting plus k, we put -1. If we were to see x squared minus 1, the effect on the graph would be that it would go down 1 unit. That's the only change that is happening. I know it's going down because it is not in parentheses. 2, I believe your paper says x minus h, but h is a -3, so minus negative becomes plus a positive 3. Remember that whatever is on the inside moves left or right, and it is always the opposite of what we naturally do. So if x is positive, we usually go to the right. So for this unit, we go to the left, 3. They tell me a is -1, so I replace a with a -1, x squared. A negative in front reflects your x-axis. The 1 is normal, so it does not stretch or compress, and we have nothing else listed to make a change. Problem 4, we have an A value of 0.4. 0.4 is less than 1. Because it is in the front, it is going to compress or stretch. Because it is less than 1, it is compressing. So it compresses by 0.4. That is the only thing that is listed that is not an x squared. Problem 5, we have two things happening. They tell me to replace A in front with 3 and K in the back with 2. So A in the front being 3, 3 is a big number because it's in front. It's going to stretch or compress. Because it's a big number, it's going to stretch. And then plus 2 in the back is not in parentheses, so we're talking up or down. If y is positive, it goes up 2. For problem 6, we replace h with 4 and k with -5, and this is the equation that we get. The change is a -4 on the inside. Inside goes left or right, and it's always the opposite of what we see. So a -4 is going to go to the right 4. And then a -5 that follows is going to be your up and down. Up and down is as is, so a minus takes us down 5. The last one, they tell us A equals H equals K equals 4. So all of these letters that we see are being replaced with 4. So there's a 4 in front, 4 on the inside, 4 on the outside. The 4 on the inside tells us it's going to stretch by 4. I know it's stretching because it is a number bigger than 1. The -4 on the inside tells me I'm going to go to the right 4. I know it's right because it's a negative and it's always the opposite. I know it's right because it's inside with the parentheses. +4 in the back tells me I'm going to go up 4. I know it is up because positive means to go up, and I know it's up or down because it's in the very back. So when you do your assignment in just a little bit, having this section out or this paper out, the purple paper from yesterday, and constantly referencing that is going to be very helpful. On the back, they tell us, problem 8, let f of x equals x squared. The function g of x is shown below. Determine the steps that transform the graph of f of x to g of x. So this graph is g of x. They tell me g of x is shown. And they want me to let f of x be x squared. So I'm going to go ahead and graph x squared just so I can see what happens. Remember, x squared starts at 0, 0 and goes out 1, 1. So that's our basic box, the 1, 1, 1. Now the transformations that happened, I'm going from this vertex to this vertex. I can see that my vertex moved to the left 3. My vertex went down 2, so now I'm here. My graph was up here, but now it's down here, so it reflected. And the only other thing it could do is stretch or shrink, so let's check that. Like we've been saying, vertex 1, 1, 1, 1, if you can make that little box, then you're good. So from my vertex 1, 1, 1, 1, these points do not fit perfectly on my graph. If you notice, instead of 1, 1, it goes 1, 2, 1, 2. So this means it is being stretched by a factor of 2. So for these, you will always go out 1. However far down or up you go is your stretch factor. So because we went down 2, it's being stretched by 2. Now the one that matches this, a reflect needs a negative. Stretch by 2 needs a 2 in front. Left needs a +3 on the inside of the parentheses. And down 2 needs a -2. So these all have the down 2. These don't have the +3. That doesn't have the stretch. So B is my correct answer. Remember, if you're looking at this like on your assignment later today and you're like, oh my gosh, I have no idea what I'm doing, plug them into y equals and see which one looks the most like that graph. If you plug in A and you do negative x plus 3 squared minus 2 and look at your graph, this one looks fatter than that one. So if you try answer choice B and do insert a 2, negative 2, that looks more like that because it's skinnier. So you just have to be on the lookout for small, swift changes like that. Problem 9 asks me to describe the transformation of the graph of f of x equals x squared that produces the graph of g of x. Write the new equation and graph. So they're telling me g of x is negative f of x plus 4. So f of x is x squared, so we replace the f with the squared on the back. Basically, you take this and make it look like that. So the only change that we did is put a squared and got rid of the f. So the effects, what will it do? A negative in front is going to reflect it. The plus 4 on the inside is going to move it to the left 4. So I draw that, I move to the left 4, and I reflect. Remember, my 1, 1, 1, 1 works as long as I don't have anything listed and there's nothing listed in front. But because it's a negative, I have to reflect and go down. So I move my vertex from 0, 0, I go to the left 4, and then I reflect it. So this one's on top, it needs to go on the bottom. Okay. My vertex is listed at negative 4, 0. And my axis of symmetry is always x equals x from the vertex. Problems 10 and 11 have kind of been started for us, or some ghost help, if you will. So for each of these, describe the transformation if f of x equals x squared that produces g of x, and write the new equation. So again, we know f of x is being replaced with x squared. So whatever you start off with, basically you take that f of x and replace it with x squared. If you have parentheses like we did on problem 9, then you leave the parentheses there so it looks very similar just with a squared. If you don't have parentheses, don't create parentheses. My vertex, just by looking at this without drawing it, is always going to be the opposite of whatever is inside with x. In this case, because we don't have anything inside with x, there are no parentheses, it's a 0 because there's nothing listed. And then it will always be the same as whatever your y is. So the negative 2 comes straight down. You'll see what I'm talking about better on problem 11. So my axis of symmetry is x equals 0 because that is the 0 from my vertex. So problem 11 has been done for us, but make sure you're really paying attention because this is what you're going to do on your assignment. Instead of the f, we have parentheses, so I bring my parentheses down, the f turns into a squared, and I bring the minus 8 down. To find my vertex, it is always the opposite sign, so negative 6 turns into a positive happy 6. It is always the same as my y, so negative 8 is negative 8. So your vertex comes straight from the opposite number inside the parentheses and the same number that follows the parentheses. On problem 10, if there's nothing inside the parentheses or if there's nothing that follows, you use a 0 as a placeholder because there's no movement. And then my axis of symmetry is always x equals the x from my vertex. So on these, remember you're doing the same thing we did. We started some of it for you. Make sure you are able to identify your vertex from the equation. This looks very similar to our notes. Notice down here, 14, 15, 16, you're asked to pick 2. You can delete 1, so choose one of 14, 15, or 16 to skip. And then we have some EOC review to finish us off.